Let's take a moment to look at what's called solubility, this concept of it, and what it really means. So sometimes solubility is given as an amount, like the solubility of something being dissolved in water. It's given an amount of solute per 100 grams of solvent. So the solubility would be 45 grams per 100 grams of solvent. Often we talk about these with ionic compounds and water. There's other types of solubilities, but this is the one we predominantly would see. Now, when we think of this, this is dependent upon the intermolecular forces between the solute and solvent. You might have induced dipoles like carbon dioxide and water, to where this induced dipole is strong enough to dissolve some carbon dioxide, however, not a huge amount. You also have ion dipole attractions, like with ionic solids like sodium chloride. You know that you can dissolve quite a bit of salt that you find on your table into your water because of the fact that these attractive forces are quite high. Hydrogen bonding plays a big role. When we think of things like water and ethanol, both have hydrogen bonding because they both have an OH area. These will mix with what's called due to entropy. Now, entropy is a different concept. I think it's one of the most, not vague, it's kind of like hard to understand because it's not as obvious. And let me go through it. Entropy is one of the universal areas of energy that wants to be highest. So highest amount of entropy, highest amount of randomness. Now, entropy is this energy randomization in a system. Energy wants to be more spread out. This is the idea of the universal theory right now of the Big Bang, and that eventually our universe is going to be so spread out that there's going to be no energy consolidated in an area, just going to be spread out. So entropy is this idea that things naturally want to spread. The kinetic energy of components are more spread out, the energy of the system is lower. So when we have water, 100% water, and some ethanol in separate containers, that entropy is pretty low. It's not very random. You put the two together, dump them in, over time they're going to spread out and not just be one area, even if you don't mix them yourselves. So the idea is that energy does not isolate itself out, it spreads out. This is another reason why when you have a hot cup of coffee I've got next to me, it's going to spread its energy out to the mug, to the surroundings, to the countertop, which is going to spread it out even more. It's very hard to isolate any source of energy, and this is due to entropy. So entropy, this weird concept, is that things are going to want to spread out. So if you started off with two different substances and you remove this barrier in between, they're going to want to naturally mix together. Energy never wants to stay in one place. It spreads to its surroundings. Just like when you turn on your hot electric coil at home, it spreads to the surroundings. We use this in order to bake and cook. This is natural. As long as there's nothing preventing them from doing this, they will. This is the concept of entropy. So how does this relate to solubility? Well, this deals with the interactions that we have. So if we have the solvent and the solute has a greater interaction than the solute to itself, what's being dissolved, or the solvent to itself, we get a solution. If they're equal, I don't know how they could be equal, but let's say they are, then it's going to also form a solution. It's going to dissolve. If the solvent and the solute is less of an attraction than the solute to itself or the solvent to itself, it may or may not form depending upon relative disparity. Most likely we're going to go towards the idea that it's not going to form. It's going to form a solid, right? So this is a reason why if you drop a coin in water, it doesn't dissolve, because the attractive forces between the metal ions and metal atoms is much stronger than the metal to the water, right? Because remember, these forces contribute or oppose the formation of a solution, right? Ion dipole is very strong, but again, that's because it's an ion. Like I said, in my metal atoms, they're not ions, they're atoms. You got hydrogen bonding that can play a role, dipole, even dispersion can do this. This is why intermolecular force is so important. Okay, need to explain this having similarity, not just like dissolves like. That's the little phrase that gets thrown out there and thinking that's going to make it as your explanation. You want to go to the intermolecular forces to describe why a solution would form or not form. All right? Come in with any kind of questions, and I'll talk to you later. Take care. Bye-bye.